other couple things that we're going to talk about before I pass this around. One is the relief cut. Now this is a little cut that starts here at the waist and goes all the way around the guitar to the other waist. This was discovered when we did the work with Purdue University. We recognized that the primary vibrating and tone creating surface was about where my hand covers, the size of a good dessert plate, you know, and I like my dessert. So we figured that out, that it was about like this. Now that's because the outside edge of the guitar where it joins the sides, it's pretty stiff. There's not a lot of movement going on there, so you don't have tone and volume. So by doing this relief cut, we moved the transfer function of the guitar out towards the edge. We got more movement of the top all the way out here at the boundary edge. Another nice byproduct of that is it makes the guitar a little more forgiving for humidity changes, because the top can stretch along those edges, where typically if it was still at its regular thickness and you dried out your guitar, you could see a top crack up here. So it's a little more, you know, it gives it some sponginess there. For performance, you get more tone, more volume, and it's just a little more durable. So that's the relief cut.
How long have we been doing that now?
2003, but, you know. Okay. So the other thing that we'll pass this around, and then we're going to play guitars here in 2 minutes. We're going to take the neck off the guitar. Now, typically, there's 3 bolts in the guitar, and there would be 2 here in the heel, 1 here under the paddle of the neck. Now, this is probably the most important thing you can notice when this guitar goes around. Borrow the neck back. The most critical part of the playability of your guitar is what's called the neck angle. That's the angle that the neck joins the body. I'm going to exaggerate it here for a second. If it's too low, the strings are going to be really high off the fretboard and hard to play. If it's too high, if it's the opposite direction, the strings are going to be laying on the fretboard and buzzing. You're not going to get much tone or volume out of the guitar. Now, imagine you line up 100 guitars. One of those out of that 100 is spectacular, right? And one might not be so spectacular. But the best one of the bunch, what you're going to find about that is all of the geometry is perfect on that guitar. Every little bit. The top radius, the neck angle. And so what if you could control that geometry to be perfect every time? That's what the NT neck does. With these 2 shims, you'll see a -6 and a 0 in here. They're tapered on our laser and cut. So we can control that neck angle at 2/1000ths of an inch increment. So we're holding metal tolerances with wood. What's great about that is as your guitar ages, as it settles, as you change, you know, where you live across the country, or it goes through several season changes, if your guitar ever needs a neck reset, you can do it at a local repairman can do it. It's going to take 20 minutes to a half an hour, and it's going to be as perfect as the day it left the factory. Let's talk about the neck for a second. Now, when we did this NT neck, the first major benefit is, again, neck angle, playability. Over the lifetime of your instrument, it could always be perfect. Second thing that happened was there used to be a thing called the 14th fret neck hump. So at the 14th fret, on a traditional glued-in set neck guitar, as the guitar would settle and the geometry would change, you get the 14th fret would be a little higher where it joined the body, and then it would fall back off. Your guitar would never play as good because that's the high spot now. So you'd either have to keep lowering that 14th fret or you have to put a higher saddle in. It was always a juggling act. Now by putting meat on the back of the fretboard, we don't glue the fretboard to the top. We got rid of that part of the flex of the neck. So it's real stable, no more 14th fret neck hump. The other big portion of this is this neck. Can you imagine a 4x4 chunk of lumber? They used to take a 4x4 and cut a neck out of it. Where'd all the wood go?
Sawdust.
Sawdust, that's right.
Shavings.
What happens any time you take wood away? You cut wood. What's the remaining part want to do? It's going to want to relax, right? You take away some wood, it's going to move. So what we do is we actually make a 3-piece neck. And some huge benefits here. First off, conservation. we get 3 necks out of that same piece of 4x4 than that a traditional maker gets 1. Tropical American mahogany is going to be hard to get. It's the new coming treaty wood. And so people are talking about it already. We have a 10-year supply of neck wood stashed around our property and around the country. We've known that for a long time, that mahogany was going to be a valuable resource. So you get the conservation. Second thing, the way that we cut our necks, when you cut a neck like that, you let the wood relax. It's going to move and do what it wants to do. Then we do the next process, remove a little material, let it move again if it's going to move. And finally, the third time we mill this neck, cut the shape, it's done relaxing, it's done moving, so you get a super, super stable neck. You don't ever hear stories of, I have a twisted tailor neck. It's twisted. It's because our necks are super stable because of our milling process. The question?
You don't have, there's no steel rod or anything in those.
Yeah.
Yes, there is. There's still a truss rod inside this. Yeah.
Well,
So-
I thought maybe there was, but I thought the way you were talking, maybe there wasn't.
No, there's still a truss rod in here for neck relief.
That's what you just a neck with.
Right. Now, the other thing that happens is with a 3-piece neck, we stack the heel on here, we glue the headstock back on and it's from the same piece of lumber when it's all cut. We save that, this neck is made from the same length, but our neck joint is stronger than a solid neck. So if this were a solid neck and we stood on it, it'd take 100 pounds of pressure to break the headstock off on a solid neck. Our initial NT neck that we started in the year 2000 had a finger joint. It looked like this. It's headstock glued on. That joint would break at 150 pounds of pressure. This new preloaded scarf joint on this one that I'm going to pass around, this breaks at 200 pounds. So it's twice as strong as a solid neck. That means if your guitar falls over or gets pushed on in any way, it's less likely to break at the headstock as a solid neck.